Once this desiccant picks up moisture, you have to liberate the moisture from the desiccant material. So we take in ambient air, we go through an ambient air filter. That filter then goes through a blower. Once again, it goes through a heater. The amount of heat that this uses is a function of the amount of moisture that's on the resin and the temperature of all the conditions. So what'll happen is if there's very little moisture in the system, there's a system called intelligent regeneration. It'll automatically match the amount of energy we're using for reactivation to the amount of moisture that has to be liberated. So typically in the summer months, the regeneration temperatures you'll see will be slightly higher than in the winter months. In the winter months, you'll have temperatures as low as 300 degrees Fahrenheit in order to liberate the moisture from the desiccant material. In the dryer circuit, we have a system that is included in all dryers called Overdry Protection. Resins have the ability at times to be over-dried. If you look at a nylon material, nylon as a resin is chosen because it's both structurally a strong resin and it also is a very flexible resin. So when you want to maintain those properties, you want to maintain the properties of the resin. If you over-dry a nylon material, what you end up with is brittle parts. Typically a nylon may come in at something like 4,000 parts per million, and you want to get down into the 500 to 800 ppm type of range. Rather than, if we over-dry that material and we get down to a resin moisture of 200 parts per million, what you end up having is you lose some of the flexibility properties of that resin. This could be nylons, it could be PBT, it could be TPUs. On the other hand, sometimes you got things like PET, and you want to dry those down to very low drying levels, and it'll automatically react to those systems automatically.